In this video, I will show you how to find unknown angles and arcs when you have segments, chords in some cases, that either meet inside the circle, or later I'll show you how to solve the problems when we have these segments that meet outside the circle. All right, so basically there are two formulas that we're going to be dealing with. In fact, let's just jump on over and talk about those two formulas right now. You know what? I feel like we should do a quick review actually. So first we learned about central angles. So forgive my horrible circles. So we learned that when we had an angle whose vertex is right at the center of the circle, okay, so for example, say if we had this, then if this is the angle and this is the arc, okay, right here, then we learned that the angle is equal to the arc. All right, so that's central angles. And you know, notice if I extend these, that doesn't change anything. All right, it's because most of our diagrams are going to look a little bit more like this going forward. Okay. Then we learned about something called inscribed angles. So an inscribed angle is when you have an angle whose vertex is on the circle. Okay, so this was when the vertex is at the center. So this will be when the vertex is on the circle. Boom. And the relationship was this. If I call the angle theta, and I'm going to again call this arc out here x. In this case, the angle does not equal the arc. The angle is going to be half the arc. So that's the relationship when the vertex is on the circle, inscribed. Okay, so now we're moving on to a new situation. When you have an angle where the vertex is in the circle. So I'm just going to put in. I'm going to be careful not to hit the center this time because we already talked about that. We already know what happens when the vertex is at the center. So this, I'm specifically making it so the vertex is not the center. So notice that I'm going to have an angle here, and this would be the same on either side because vertical angles. But notice that I'm going to have two arcs now. All right, I'm going to have an arc over here, and I'm going to have an arc over here. So I'm going to need two different variables because these are not the same size. So this is x, and this is y. And it turns out that the angle is going to be the average of these two arcs. So in other words, the angle is going to equal arc plus arc divided by 2. All right, that's how you take the average of two things. And then the last relationship we're going to look at today is what happens when the angle vertex is outside of the circle entirely. All right, so let's say we have a situation like this where the angle goes outside the circle. All right, so in this case, this is my angle right here. Now again, I have two arcs. All right, I have this smaller arc that's right here, and then I have this larger intercepted arc that's right here. Okay, I'm going to call the big one x and the small one y. In this situation, it matters which one is big and which one is small, because we're going to subtract, and it matters, like the order in which you subtract. So you're going to see that this formula I'm about to write down is almost the same as this, but instead of being x plus y, it's going to be x minus y divided by 2. That's the only difference. All right, and of course it has to be big minus small. All right, it has to be the big arc minus the small arc. Otherwise, you get a negative number, and that's no good. Okay, now let's jump over and do some problems. So of course, these first two problems are this first situation where the angle is inside the circle. So we're going to be using this formula, arc plus arc divided by 2. Okay, let me zoom in. So remember, the formula goes like this. All right, angle equals arc plus arc divided by 2. So that's what we're about to do. Now the angle is what we're looking for. So I think just instead of question mark, I'm going to go ahead and call that x right now. So I'm going to put that in for the angle. So that makes this angle is equal to arc plus arc divided by 2. All right, and that's it. So we just need to calculate that out. All right, so this is going to be, what were those two arcs again? Yeah, 190 and 50. So we have 190 plus 50 divided by 2. All right, so that's 59 halves, or 29.5. All right, so that's the answer number 1. All right, same situation. We have the angle is inside the circle. All right, so this is an inside the circle problem. And the formula again is angle is equal to arc plus arc divided by 2. So this time we're given the angle. So that's why 130 degrees is going to go right here. All right, now as far as these arcs, the arcs that we're talking about are here and here. Now, one of those arcs is the arc that we're looking for, so I'm going to call that x. So we're going to go 210, that's too big, plus x, all right, arc plus arc divided by 2. So it's just a matter of how do we solve this equation. Well, we're trying to get x by itself, but we have this denominator. So the best thing to do is to start by multiplying both sides by the denominator. That way you can cancel these denominators out. So that's going to give us 260 is equal to 210 plus x. Then we can subtract 210 from both sides. So we're going to get x is equal to 50. Okay, so that is 50 degrees. So that's it for number 2. So next we have an angle that is outside the circle, all right? So this is an outside the circle problem. Now the formula for that is almost the same as the in problems. But instead of being arc plus arc, it's arc minus arc. And make sure we do the big arc minus the small arc, by the way. So let's just start by writing down the formula. So we know that the angle is equal to arc minus arc divided by 2. And that's the big arc minus the small arc, please. So the angle, in this case, is what we are looking for. So I'm going to go ahead and call that x for us. So that means I'm going to have x is equal to arc minus arc. So 151 minus 81, right? Divided by 2. Because those are the arcs that we are talking about, all right? Here's one arc is the 81, and the other arc is this 151. So we should be able to just put that in the old calculator. What was it again? 151 minus 81. So we have 151 minus 81 divided by 2. So that's going to be 35. So that's how you do number 3. So here's another outside the circle problem. All right, and when you have the angle outside the circle, the formula is angle is equal to arc minus arc divided by 2. And please, please make sure that this is going to be the big arc and this is going to be the small arc. In this case, we're given the angle. The angle is 40. So that's why I'm going to put the 40 here in for the angle. All right, now the two arcs that we're dealing with are this one and this one. Okay, I'm going to call this X since this is what we're looking for. And this is the big arc, so I'm going to put that first. And then minus the small arc divided by 2. So it's just a matter of solving this equation. Now, we need to get x by itself, so the best thing to do would be to multiply both sides by 2. That way you're canceling the denominator out. And that's going to give you 80 is equal to x minus 42. And then we're going to just add 42 to both sides. So that's going to give us x is equal to 122 degrees. Here comes another outside the circle problem. So the formula for that again is angle is equal to arc minus arc divided by 2. Okay? So the angle is what we're looking for. So I'm going to call this x. So I can just go ahead and put x right here. Now, arc minus arc divided by 2. We need the big arc, which is 210. All right? Because understand that the big arc is this right here. All right, and then the small arc picks up from there and goes like this. All right, even though they meet at the point of tangency, this is two different arcs. That we got the big arc and the small arc. So 210 minus 70 divided by 2. So that is 70. So that's number 5. All right, here we have yet another angle that is outside the circle. So that formula is angle is equal to the big arc minus the small arc divided by 2. So they gave us the angle this time, so that is 37. So I'll go ahead and put the 37 is equal to, the big arc is 125. The small arc is the thing that we are looking for, all right? This is the small arc right here. So that's x divided by 2. And of course, our first move will be to get rid of the denominator by multiplying both sides by 2. That way we can cancel these out. So this is going to give us 74 is equal to 125 minus x. Okay, so if we subtract 125 from both sides, okay, that's going to give us negative. So if we do 74 minus 125, that's negative 51. So if negative 51 equals negative x, then that means 51 equals x. Right? Technically, we're dividing both sides by negative 1. Anyway, that's going to be the answer to number 6. All right, so we're back to being inside the circle. All right, so this is going to be an inside the circle problem. And the formula for that was that the angle is equal to arc plus arc divided by 2. All right, so in this case, they gave us the angle. All right, the angle is the 56. So that means I have 56 is equal to, now, arc plus arc. So one arc is this 54, and the other arc is 8x minus 6. So I have that divided by 2. Okay, and it looks like they want me to write this equation over here for some reason. So I'm going to go ahead and do that. All right, so fine. That's the equation, and now we just have to solve it. So I'm noticing that we have some like terms. All right, so before we do anything else, these are like terms. So that's going to be 48 if I put those together. Okay, so that's going to give me 56 is equal to 8x plus 48 divided by 2. All right, then it will be time to multiply both sides by 2 so we can cancel out those denominators. And then, so that's going to give us 112 is equal to 8x plus 48. And then we would subtract 48 from both sides, right? So now we have 64 is equal to 8x. And then we divide both sides by 8 to get x by itself. So x is equal to 8. So that is how you do problem number 7. So here's another outside the circle problem, all right? So this is an out problem. And the formula for when you're outside the circle is angle is equal to the big arc minus the small arc divided by 2. Okay, so in this case, they gave us the angle. So that's going to be 55 is equal to, all right, I'm going to need a little bit more space, I think. So we'll need the big arc first. So the big arc is 3 plus 15x, all right, minus the small arc, which is 58. All of that is going to be divided by 2. These parentheses aren't really doing anything. There's nothing in front of them, so I'm just going to ignore the parentheses. And I'm going to concentrate on these like terms. All right, I've got the 3, and then I've got the minus 58. those are about to go together. So that's why I'm going to have 55 is equal to 15x minus 55, all right? 3 and negative 58, that's negative 55 divided by 2. So of course now we will multiply both sides of the equation by 2 so that we can cancel out the denominator. So that's going to give us 110 is equal to 15x minus 55. Now it's time to add 55 to both sides. So that's going to give us 165 is equal to 15x. And then we will divide both sides by 15. $11. So that is how you do number 8. All right, here we have another outside the circle problem. All right, so this is another out problem. And when the angle is outside the circle, we know that the formula goes angle is equal to the big arc minus the small arc divided by 2. They gave us an expression for the angle, that is x plus 40. So that's why I'm going to go ahead and put x plus 40 first. Okay, now the big arc is 139. The small arc is 59. And that's all going to be divided by 2. So that's my equation. The right side of the equation has no variables in it. So normally I would multiply both sides by 2. That's not necessary because we have no variables. So there's no reason why we can't just simplify the right-hand side on its own. So what do we have? 139 minus 59. All right, so that's 40. So that's why the right-hand side of the equation is simply going to be 40. Now on the left-hand side, we have x plus 40 is equal to 40. Okay, that's interesting, because when I subtract 40 from both sides, then that means that x is going to equal 0. All right, which is okay, because that just means that angle D is 40, you know, like 0 plus 40. So it doesn't mean that we have an angle with no size. It just means that it's 0 plus 40, which is simply 40. All right, so this angle is 40, and if we do this minus this divided by 2, we get 40, so it makes sense. But x is 0. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.